today, I want to take a look at, whoops, I missed my E in there, piecewise functions. All right, now they are exactly what they sound like. Piece, all right, they are in pieces, all right, and they're pieces that you are familiar with, all right, in the sense that the pieces are going to be made up of straight lines, parabolas, x to the thirds, maybe absolute value, which are v's. So all the graphs you already know are going to be made up with this. All right, now very straightforward, simple process to do this. All right, if you follow it step by step. Okay, so let's say I'm going to come down a little bit. Okay, so I'm coming down a little bit for a reason. Okay, say f of x equals, all right, and then a great big bracket like that. If it's in pieces, I have to have pieces. Okay, I've got to have pieces. All right, Drew, we need you to have your mask on, please. So let's say the first piece is that x plus 1 if 0 is less than or equal to x is less than 3. All right, and then there's always going to be conditions. All right, so here's our first piece. All right, and here's some conditions with which we will deal with this piece of the graph. All right, let's say we have another piece that just has a 3 here, and then it says if x equals -1, and again, a condition based on this piece of the graph, and then maybe say an x squared if x is less than -1. All right, now just glancing at this in general, I have 3 pieces. This should look like a line to you, y equals x plus 1, straight line, slope-intercept form. Y equals 3. All right, this could be a horizontal line, or it could be a dot, and that is based on whatever we see over here as our condition. All right, and then this, y equals x squared, you should be thinking, oh, hey, I got a part of a parabola. So you should recognize your pieces before you even start. Okay. Now, the first thing we're going to do is we're going to like sketch these, graph these out. Okay. The easiest way to do this is to use ordered pairs and to take each piece individually. All right. And deal with them on a one-on-one basis. All right. So I'm going to take this number right here. These numbers over here are x's. All right. So right here, x is 3. So what I'm going to do is I'm going to generate an ordered pair. If x is 3, I can take 3, plug it in here. 3 plus 1 is 4. And I've just generated it in an ordered pair. I can do the same thing here. This is a value of x. So my ordered pair starts out with 0. I can take 0, plug it in. 0 plus 1 is 1. All right, I have 2 ordered pairs now that deal with this line. So what I'm going to do is I'm going to come over here. I'm going to give myself some hash marks. Okay. All right, now, when I plot these points, I have to decide whether they are closed dots or open dots. All right, this point, this 3 is right next to this less than sign, and less than sign would mean we would not include the point. So that's going to tell me an open dot at 3, 4. All right, this 0, 1 right here is right next to the less than or equal to sign. The equal to part means it is included. The equal part means it's included. So this would be a solid dot. So I'm going to go to 0, 1, plot 0, 1, and a solid, make it a solid dot because of the equal to part. Then I'm going to plot this point, 3, 4, and I'm going to make it an open dot because of the less than sign. Okay, now I know it's a line, right? Straight line has a positive slope at 1. If I connect them, do I have a positive slope of 1? It's going up and to the right. I do. Straight line, so all I got to do is connect them. This entire line would be what? The entire line that goes on forever and ever and ever, right? It's the entire line that goes on forever and ever and ever. Somebody want to answer that door and let him in here? And then, but because of this condition, this says 0 is less than or equal to x is less than or equal to 3. He's such a good man delivering. Thank you very much for passing them out. Yeah. All right, so x is going to be in between, this line is going to be in between the values of 0 and 3. Well, here's 0, here's 3. All right, there's the only portion of the line. This line as it sits, y equals x plus 1 would be the entire line. I don't want the entire line, I want just this portion of it. Okay, so there's the first piece. All right, now we're going to color code this. All right, now again, on this piece right here, I want to make an ordered pair. My x value is -1. All right, now if I go to plug it in, I really can't plug it in, right? Because there's no x there. All right, but technically, isn't there an x to the 0 power? Like anything to the 0 power is always 1. So if you literally want to plug it in somewhere, okay, I can plug it in. -1 to the 0 power is 1. 1 times 3 is 3. All right, if you don't need to do it that way and just go, oh, there's no place to plug it in, my y value has to be 3, then your y value is 3. But technically, any number has an x to the 0 power next to it. X to the 0 power is 1. So that's why we don't write it. Okay. Now, because there's no, notice how this has a variety of x's from 0 to 3, right? It's a long section. This, I didn't do it. There's one x value here. So this is not a horizontal line. Y equals 3 is normally a horizontal line, right? But it's not, I'm not providing you with tons of x values. I'm providing you with one x value. One x value, one y value makes a single point at -1, 3. So literally on that, that's the only thing that you have. -1, 3 is a solid point. All right, I don't know if that's coming off purple or not, but it's supposed to. All right, now if x is less than -1, all right, x is 0. I want to create an ordered pair. So I've got a -1 here. I'm going to take -1, I'm going to plug it in here. -1 to the second power is 1. Okay, Rachel?
I have a question. How do you get x to 0 power?
I just added that to it. It's the number 3, right?
Yeah.
And so if I had an x to the 0 power there, isn't x3, x to the 0, same thing as a 3? Because what is x to the 0 power? 1, right? Anything raised to the 0 power is 1. So 3 times 1 is 3. So a single number 3 is the exact same thing as a 3 x to the 0 power because of what anything raised to the 0 power is. Is that better? So, and the only reason I put it there is because if we're taking these values and plugging them in for x, if you want to do that here, you plug it in here, and it doesn't matter what the number is because anything raised to the 0 power is always 1. 1 times 3 will always give you a y value of 3, but for the consistency there. All right, so we've got the -1, 1 point generated from here. I'm going to look at the sign that's right there, which is a less than sign. That's going to tell me open dot. So at -1, 1, I'm going to have an open dot. All right, now stop and think about this. This right here is a parabola, right? It's a parabola. Where's the vertex of this parabola? Where's the vertex of this parabola? If I just wrote that as y equals x squared, where's vertex? Vertex is at the 0, 0, origin. Somebody said 0, 0. All right, so technically this, I'm not going to draw it because I don't want to mess up the picture, but the vertex is right here, and it would go up through that point and go up there, and then it would go up here, right, because positive coefficient, so it would be an upright parabola. All right, but I don't want the entire parabola for a variety of reasons, and I'll tell you why in a minute. I have to base it on this condition. This says x is less than -1. Well, right here's -1. All right, so where's the values less than -1? It would be all over here, right? These values are less than -1. So I'm not going to draw the entire parabola. I'm only going to draw the portion of the parabola, which is less than -1. But if I were to draw the entire thing, it would come down, the vertex would hit right there. At the origin, it would go back up. All right, now the reason I can only have this portion is because I told you that this was a piecewise function. If this is going to be a function, it has to pass the vertical line test, right? It's got to pass the vertical line test. If I were to draw the rest of that parabola all the way over here, would it pass the vertical line test? It wouldn't pass the vertical line test. And it has to be a function. All right, now, let's say I draw the vertical line right down here. How many times did it cross the graph? It crossed it here because this is a solid point. Okay, that's once. Did it cross it here? Because it's an open dot. So it does, when I draw the vertical line for the vertical line test, right there, I still pass the vertical line test because this is solid and this is open. Okay, so it really does pass the vertical line test. All right. Now from there, you could, we have been doing domain, we've been doing range, we've been doing what x-intercepts, we've been doing y-intercepts. All right, all of those things, I should be able to ask you about any of those, all right, on this. Let me go glance and see what you did yesterday. You did decreasing, increasing, you did x and y intercepts, we reviewed that, zeros, domain and range. Okay, so every time you do that, then that little thing comes back up. All right, so let's do some of those things. Let's see. Let's do some of those things. I'll do them in green. Let's do domain. Let's scribble that out because we don't need that anymore. All right, domain. Domain is left to right, right? Left to right across the graph. You start all the way over here. This portion of the graph goes, yes, it goes up, but as it's going up, it's also going to the left infinitely because there's an arrow on the end because parabolas go forever and ever and ever. So negative infinity is down here. So we start at negative infinity. Every value, every x value is included until I get up to the number 1, negative 1. It's not included here, but it's included here, right? There's a solid point right there. So negative 1 is in my domain because of that solid dot right there. So I do negative 1 and I choose a square bracket because it's a closed dot. If I'm looking left to right across this, there's no x values in between negative 1 and 0, no x values. So then that means there's my gap in my graph. All right, and then where does it pick up again? It picks up at 0 right there. The graph picks up at 0. Okay, and it's a closed dot. And then every x value is included all the way to 3 because this is 3 right there. Now, what kind of bracket do I need on 3? Curvy because it's an open dot. Okay, so we can do domain, we can do range, we can do x and y intercepts, we can do zeros. All right, here, let's do a real fast one over here. Zeros. Are there any zeros to this function? Are there any zeros in this function? Does the function cross the x-axis? No, zeros are the same thing as the x-intercepts. It doesn't cross there, so there are no zeros, none. All right, so then from there, because I'll do range in a minute, x-intercepts, if there's no zeros, there's no x-intercepts. All right, however, do I have a y-intercept? I do have a y-intercept, right? Y-intercept is the ordered pair 0, 1, because it crosses the y-axis at 0, 1. Okay, so those were easy. That's why I just threw those in before we did range. All right. If we're doing range, what are we supposed to look at? We're supposed to look at the y values. We start at the bottom and we go up. We start at the bottom and we go up. So no y values, no y values, no y values. What's the first y value? 1, right? Closed dot. So first y value is 1 with a closed dot. All right, now for this portion of the graph over here, if I'm going up, this portion over here includes every y value from 1 to 3, right? So, okay, that's great. Okay, but how about if we focus on this part of the graph right here? 1 is not included there, but it is here. So 1's definitely in my range. But then this part goes up forever and ever and ever and ever. So it doesn't really matter what's going on over here. Over here, this portion right here tells you that every y value is included all the way up to positive infinity. All right, so 1 to positive infinity. So that's the thing with piecewise functions, is that you have to decide, well, where am I going to look on the graph, because it's not always the same place every time. It's not always the same place. Okay. All right. Let's see. So we've done domain, range, zeros, x-intercept, y-intercept. Okay. Could we do function values? Could I ask you for f of 0? And could I ask you for, well, actually, let's not do f of 0 because I'm going to be a little bit more specific than that. Let's do f of 1. Let's do f of 1, and let's look at f of 3. All right, now function values. This is just function notation, right? We've done function notation since algebra 2. This says take 1 and put it in the function. All right, well, isn't this my function up here? All right, well, I got lots of places to plug it in. Where do I choose to plug it in? This is really f of x or f of 1. So this is an x value right here. So I got to come over here and figure out, well, where is 1? Is 1 equal to -1? No, so I don't want to plug it in here. Is 1 less than -1? Nope, so I don't want to plug it in here. Is 1 in between 0 and 3? Yep, so I want to plug it in right here. So when I plug in 1, 1 plus 1 is 2. Can we verify that on our graph? Yes, we can. Go to the x value of 1 and go up to where the function is. And that point is right there, spits out a 2. So it is on the graph right there. Okay, now, if I want to plug in f of 3, if I want to do it from an algebraic standpoint and I look right here, all right, well, this says x is in between 0 and 3 is not included. So can I plug it in here? I can't plug it in there. Okay, and obviously it's not here, and obviously it's not here, so I don't have any place to plug it in. So then, okay, you're in panic mode at that point. Okay, so then you've graphed it. Go look at your graph. This is my x-axis, right? Go to the x-axis to where 3 is, because I want to evaluate f of 3. Now, go up to where the function is, and I find an open dot there. So what's my answer to f of 3? Starts with a U? Somebody said it, undefined. It's undefined.
So does an open dot make it undefined?
The open dot makes it undefined because the open dot means it's not included. The less than sign says it's not included. It's undefined. That portion of the function is undefined. All right, I could also do, I mean, like f of, say, 6. All right, well, 6 would be out here, right? If I go all the way up, does it ever hit the function? Nope, so that's undefined as well. Okay, the function is not defined there. All right, now stop and think about that. Is 6 in the domain? It's not in the domain because there's no function over here. So it's undefined. 3 has an open bracket on it in your domain. 3 is not in the domain. If it's not in the domain, it's not defined by the function. Okay, so lots of different ways to look at that. All right, now, granted, we've taken one piecewise function here, but like tons of things. All right, we've sketched it. We've looked at domain, range, x and y-intercepts, zeros. All right, now there are 3 other examples in the online notes so you can download and look at. You could write this portion of it down and then try to sketch it on your own. Look at the notes and see if you can do it right. Okay. And what I have done in the notes, see these little points right here that I generated? I color coded the online notes. So I did, I put this in orange and then that section is orange. I put this in purple, that section is purple. And in the online notes, it shows up really, really good. Okay, so there's at least 3 more examples of this that you should try on your home before you start your homework. Okay. All right. Now let me go back and take a glance at the